Let's make it so you can click on one of these circles and it will display as highlighted. This will be our first example of interaction and dynamic state. But first, let me talk about this concept of unidirectional data flow. Unidirectional data flow means one-way data flow. The data, or the state, it flows in a loop where when you interact with the system, something changes, and then it re-renders. And then you see the updated render, and you interact again, and so on. It works like this. When you render something on the page, and then you interact with it, that interaction is captured with an event listener. And then there's a change in the state. And then after the state changes, it triggers an updated render with idempotent rendering. And technically speaking, the fact that it's idempotent is very important. And that means that when this function responsible for rendering executes, it synchronizes the DOM to what we want it to be, and it can be invoked over and over again. Let's look at some concrete code and then circle back to this diagram. I'll start by forking this circles with D3 in React example, and I'll call it clickable circles with D3 in React. The approach that I would like to take for this is to use React for the state management. And here's our app, and it's all in this index.js. So as a first step, let's refactor this so that app lives in a separate file. Okay, great. Now we're importing app, and this is using the default export. Use a named export for app. Okay, that looks good. Yeah, this is my personal preference. Okay, so this is just the React boilerplate treating app as the entry point. And then here in app, this is where I would like to introduce a piece of state. But before we do that, let's think about what that state will represent. The idea is that I want to make it so that you can click on a circle and it will display as highlighted, just as an example of dynamic state and interaction. Considering that this is our data, how do we keep track of which thing is selected? While you could store these object references in the state, I think it's better to use an ID. And I've ran into bugs in the past when you store a reference to an object as the state. So let's first assign each of these an ID by using .map. This is a function built into JavaScript arrays where you can pass in another function. And then this is what I'll do. I'll make a copy of that datum, that element of the array, but I'll also say the ID is I, the index in the array, and that I is passed as the second argument to .map. Oh, and there's a syntax error because if you implicitly return an object, you have to wrap it in parentheses. Okay, great. Now, each of these data elements has a unique ID. And we can check that by just saying console.log data. I love that, the console.log data. That's when you know you've really gotten started. Here's what that looks like. And we can see we have these IDs, 0, 1, 2, and so on. So here's the plan. When we click on a circle, we want to set this piece of state, which we can set up with the useState hook in React. And that will just track this number, this integer, which will be the ID of the circle. Let's see how much of this we can do with AI. Please introduce a new piece of state using useState from React called selected ID, and make it so that when I click on a circle, it sets that state, and also modify the rendering so that the selected ID circle has a stroke around it. Let's see. Okay, that worked. That was pretty fast. That's the power of AI. Let's review the diff. We have added selected ID and set selected ID. Perfect. These are now additional options to the viz function. And notice how it's totally decoupled from React. The viz function doesn't need to know that React is used to implement these two. And you could implement these in a different framework if you wanted to, keeping the viz function intact. And then we just have some additional attributes. The stroke is a function that checks if it's the selected one or not. And if it is, it sets a black stroke. Otherwise, it sets none. And then stroke width is, if it's the selected one, 3. Otherwise, 0. I don't think that's strictly required if we're setting stroke to be none. We could just set the stroke width to be 3 all the time, I think. But anyway, we've got this onClick that sets the selected ID to be d.id, where d gets passed in. Perfect. Perfectly done. And here's how the state is actually set up in React. It's this little incantation, which is use state from React. Initialized to the value of null. That's what the argument here is. And then the way that this works is use state returns an array of 2 elements. The first element being the current value. And then the second element of that array is a setter function that we can call to set that value. And then whenever that function gets called, that triggers this entire app component to re-render, which also triggers the side effects. And because now selected ID is a dependency in this useEffect hook, it causes this function to run every time the selected ID changes. So that's how it works. Clickable circles. Let me just go in here and clean it up a tiny bit. We can just set stroke width to be 3 all the time, just to simplify it a little. And does that still work? Yeah, it does. Okay, great. Otherwise, that AI edit was pretty clean. That's how you can make clickable circles with D3 in React. To tie this back to our mental model of unidirectional data flow, here's what's going on. When the user interacts, that triggers an event listener. In our code, that's this one here. On click, call set selected ID. This is where that event listener is defined. As a result of that event listener, a change in state is triggered. That's what this set selected ID call does. It changes the state. And because that set selected ID function is defined by the use state hook, whenever it's called, it triggers this entire app and this function inside of it to rerun. That is this idempotent rendering part of it. The fact that we're using this D3 incantation of the data join guarantees that it is idempotent, meaning internally this handles the enter, update, and exit case. But in this case, all it does is it creates new circle elements on the first render, but then on all the subsequent renders, since the data array doesn't change actually, it only updates the rendered circles based on this selected ID, which does change every time. And we can consider this idempotent because the second, third, and fourth times that it renders, it's not going to append new circle elements. It's going to reuse the ones that are already there. So that's the idempotent rendering step. And let me close this out by saying I love this as a mental model because it includes the human in the loop. See, down here, after it renders, it triggers, perception and cognition, which happens inside a person, inside a person's head. You see the updated thing rendered, and then that ties into volition and action. So this is essentially free will. after you see the picture, you can think about it and decide what to do next. So that's unidirectional data flow and clickable circles with React and D3. Next, we will inch our way towards an actual data-driven scatterplot by modifying the data such that it's defined in a CSV file.